Now I'm going to show you how to run the analysis in JMetric with a Rasch model. So this is the binary multiple choice items test. So I'm going to go to Analyze, Rasch models, and I want to put all of these items over here. We have the item characteristics, and really I just want to save item estimates as item est, and then I want to look over here at person. We have to make sure that we save person estimates and person fit statistics for later on. And maybe we could save residuals as well, but here I'm just going to put person rid. And again, I want to just point out here in this item, you need to make sure that you check this box for save item estimates. And then we can also show start values if that's important. So let's go ahead and run. When you select that Save Person Fit Statistics, JMetric adds 4 new variables to the item response table, so that's important to note. And the new variables are the weighted mean square, standardized weighted mean squares, unweighted mean squares, and standardized unweighted mean squares. Those are the fit statistics. And that's going to show if things are good for in-fit or out-fit. And also we'll save B param, which is the difficulty. So let's go ahead and look at this. Right up here, these are, we don't need to look at those right now. But let's look down here. So here we have the Rasch model output. And we're going to look at item number 8, which seems to be the easiest number because it's the furthest from 0 in the negative direction. And then if we look at item number, let's see, item number, there we go, let's keep going down, 27, number 27 is clearly the most difficult item here. That seems kind of fishy because we've got a 2.21, a slight tendency to overfit the data, and let's see, and item 10 as well. Pretty high numbers. But let's look at the data size. Because our sample size is 6,000, it's not really indicative of poor fit. So we're going to focus on the mean square fit statistics whenever we have a large sample size. It's good to review our fit statistics and difficulty estimates for every item in the output, but it's also possible to get a quick look at the distribution of these statistics by running some descriptives. So now I'm going to analyze the descriptives. To do this, I need to look at the item estimate table that I created when I clicked the item estimate box. And I want to analyze descriptives. We want to look at difficulty level. We want to look at outfit, difficulty level, outfit, and we want to look at infit. So I'm going to run that. As you can see here, just like we predicted, negative 1.85 is the easiest, and the hardest was 2.21, so that's our range. And then we have a mean of 0. Our mean square outfit statistics range from 0.641, that's right here, to 1.4538 with a mean of 0.9926. And then our infit statistics values range from 0.8057 to 1.1748. Let's go back and look at our outfit statistics. and our outfit statistics are showing that there is a little bit of a problem here. So they're outside the desired range for a high stakes test, and that means that we might need to do a little bit more detective work here. So let's go back and look at the outfit here in this Rasch. So okay. Now we're going to look at the outfit statistics here. So let's look at item number 27. That seems to be the one of the most concern, and of course it also is the one that is the most difficult. If you can see over here, this 2.21, and that doesn't really surprise us. So if we look at the UMS score, it's a 1.45, and that's problematic. It's not surprising though, like I said. And the second largest item difficulty level, so let's look at number 32. That will be 32, the second, and let's look at the UMS there, and that's 1.33. So for these two items, difficulty may be so high that even very capable examinees tend to resort to guessing. Or it could be that the correct answer is ambiguous. So what we need to do is to look at those two items because they're probably problematic, and we need to see, what's going on here. Okay, now let's look up here at these two items for the easiest, like the opposite pattern of what we were just looking at. So item 8 is the easiest, and number 11, item 11, is the second easiest. If you look over here, they have a UMS of 0.64 and a UMS of, where do we have that? Item 8. Item 11.65. Neither of the outfit statistics are concerned, but they do suggest that easy items have a tendency for overfitting the data because they have the lowest UMS number. If you would like to quickly identify the misfitting examinees, you can subset the data to show only those examinees with WMS and UMS values that exceed your criterion. For example, select the data table that contains the person fit statistics, which is right here, exam 1, and we want to go into manage, subset cases, and we're going to come down here. You see WMS. We have WMS there, so we're just going to type WMS (0.5) or WMS 2.0 or UMS 0.5 or UMS 2.0. And we're going to call this subset. Now we'll look at subset 1, and here you can see there are 22 examinees with infit and outfit values outside the specified range. We can now look further into why these examinees are displaying misfit. We could also do the opposite and subset the data to include only those examinees that show good fit.